Alright guys, just an example of projectile motion. So here we've got our equation up here in feet per second. It's feet per second. The height of a rocket shot in the air from the ground with an initial velocity of 60 feet per second can be modeled using this equation above. We want to find a bunch of different things. Before we go to find those different things, we want to write our function up here. So we want to insert what we know. We know that it's 50 feet per second and it's shot in the air from the ground. So that gives us a couple different pieces. The first piece is the initial velocity. The second piece is the initial height. So writing our equation, we get h of t is equal to negative 16 t squared. 60 feet per second is the initial velocity, so we're going to start at 60 feet per second, so that goes in that slot. And then from the ground technically is plus 0. So we would write that here. But we know we don't write plus 0. So here's our initial equation that we're going to be working with that models the height of this rocket. Alright, so let's go ahead and try to figure out what information we need to know. Number one, how long does it take for the rocket to reach its maximum height? So how long is an indication that we're solving for t? So the maximum height, if we know this rocket is going to be shot from the ground, it's going to look something like this. Here are my axes. It's going to come up, and it's going to hit the ground right there, so it's parabolic in nature. The maximum height is going to be found at the vertex. So we need to go ahead and find the vertex. The vertex for any quadratic we know we can find using, I should use a t there, using negative b over 2a. So t is going to be negative b is negative 60 over 2a is going to be over 2 times negative 16. A is negative 16 in this case. We want to make sure that we simplify this as far as we can. So we get negative 60 over 32, negative 32. And again, simplify as far as you can. Greatest common factor that goes into both of these is going to be, let's see, if we reduce it by 4, we're going to get 15, and it's negative divided by negative, so it's going to end up being a positive. Reduce this by 4 and we get 8. So 15/8, that is the time in seconds that it's going to take to reach that maximum height. So the next question is, go ahead and go through and figure out what that maximum height is. Well, we know that the maximum height is going to be at the vertex. We've already figured out the t coordinate of the vertex, so what we need to do is figure out f of whatever that t coordinate at the vertex was. We just figured out it was 15 over 8, so plug that into your equation. So we're trying to find, sorry, not f, it's h. H of 15 over 8. In other words, plug that into your equation, so we're going to get negative 16 times 15 over 8 squared plus 60 times 15 over 8, and we're going to simplify that. So this looks like it could get kind of nasty, but let's check out what happens. Let's simplify our exponent first because of order of operations. 15 times 15 is 225. And then again, we got to apply that exponent to both the numerator and the denominator. So we're going to end up with 225 times 64, or over 64, negative 16 times that quantity. Let's simplify this. And essentially that's what's going to make it easier. So if I divide this by 4, I end up with 15. Divide this by 4, I end up with 2. So that's going to simplify to 225 over 2. Same thing over here. We can simplify this expression here. Divide it by 16, that ends up being a 1. Our denominator over here ends up being a 4. So we get negative 225 over 4. And we're going to add that to, now we need a common denominator. So this guy, 225 over 2, double both terms, the numerator and the denominator. So we end up with 450 over 4. So we're going to add 450 over 4. And from there, it's just simplification. So again, remember what we're trying to find. We're trying to find the maximum height and that happens at the vertex. So h of 15 over 8 is going to equal that. Simplify, and you get 225 over 4. That's in feet, and if we want to give an answer that's a little bit more reasonable to someone that was asking this question, we would divide this 225 divided by 4. That's going to give us 56.25 feet. So that's going to be the maximum height of this rocket. On to the next question. How long is the rocket in the air? How long tells us we need to solve for t. And how long is the rocket in the air essentially is asking when does it hit the ground. If we go back up to our little graph that we made, well, it starts on the ground and it hits the ground here. So we're just trying to find the roots here. That's going to tell us how long the rocket is in the air. So if we solve for t, we take our original equation. H of t equals negative 16t squared plus initial velocity was 60, and then we started at a height of 0. And how long is the rocket in the air means that we need to find the roots, so set that equation equal to 0. When we do that, again, this is a quadratic. Every time we have a quadratic, our first step is always factor out the greatest common factor. And that happens to be negative 4 in this particular case, actually negative 4t in this particular case. So when we factor out a negative 4t, we end up with 4t minus 15. That's equal to 0. And then we use the zero product property to say that either negative 4t is equal to 0 or 4t minus 15 is equal to 0. Go through and solve both of those. We know that it's going to be on the ground when it starts, so that's where this root comes from. And then the other root is going to be t equals 15/4, or in other words, 3.75 seconds. All right, last one. So at what time is the rocket 36 feet in the air is what we want to know. And essentially what this is saying is we're solving for a t, but we have a particular height in mind. So our h of t, remember this function models the height that this thing is. So what we're going to do is we're going to set this equal to 36. We're saying the height is 36. The rocket's 36 feet in the air. And we know that our function models the height. So negative 16t squared plus 60t is going to be equal to 36. So when is this function equal to 36? Or in other words, when is our rocket equal to 36 feet in the air? So just like any quadratic that we solve, we want to get all the terms on one side and compare it to 0. So we're going to move that 36 over. And we now need to solve this quadratic. And it's very similar. We want to take out the greatest common factor first, which is negative 4. That leaves us with 4t squared minus 15t plus 9. And so now we've got to figure out how we can go and find the roots based on this equation. That's equal to 0. So go through and solve. You've got negative 4. We need to factor this. You could use quadratic formula if you wanted to, but the first thing we always want to try to do is factor. I would suggest pausing the video at this point. Try to factor this quadratic right here. And see if you can get it to factor into two binomials. Alright, so what we end up with here after we factor, we're going to have a factor of 4t and t. We know they have to add the two negative numbers, but multiply to a positive, so they've got to both be negative. And in this particular case, we're going to end up with 4t times 3 is going to times negative 3 is going to give us negative 12. And then a 3 right there. And let's double check to make sure. The way that we double check is to just multiply it out. So first, outer is going to be minus 12t. Inner is going to be minus 3t. Last is going to be plus 9. this will give us our negative 15t that we need in the middle, so that factors correctly. So to finish up the question, we know again zero product property, either 4t minus 3, clean that up, 4t minus 3 is going to be equal to 0, or t minus 3 is going to be equal to 0. So at a time of 3/4 of a second, this rocket is 36 feet in the air, or at 3 seconds, this rocket is 36 feet in the air, and both of those work. So as it's going up, it's going to take 3/4 of a second to go up and reach that height, and as it's coming down, it takes 3 seconds to reach that height.